Thank you so much, Rob. I will have to buy you that beer that we agreed now. So thanks for that. It's all right. It's all right. You won the coin. So my name is Ismael Valenzuela, and thanks to Rob and to the rest of SANS for putting together this awesome summit. For the next 20 minutes, this is a short presentation. I'm going to try to summarize a very specific solution to a very specific problem, right? And hopefully you can get away something from this, something useful. And this is aligned to the SANS motto, right? Just get something that you can use as soon as you get back to your office, right? Get back to work tomorrow and play with something that you have seen here. And you have observed probably during the last few talks, or since we started the whole summit with Van Bisher talking about Squeal and some of the awesome stuff that he's been doing, that when you mix, when you get like a coder, right? A pen tester, a forensics guy, and an IR guy working together in a SOC, something awesome happens, right? You've got the power. We've seen this with Google and their awesome projects as well, GR and how to pronounce that, GR, whatever, GRR, right? And all of those awesome tools. Because we have issues, right? We know these issues, we know how to solve them, right? So if you have some coding skills, you can quickly put that together. And it might be quick and dirty, right? That code might hurt when you actually see it, but it works, right? So this is the story I want to share with you today briefly. So a little bit about me. He already mentioned pretty much everything. But I'm a SANS instructor. I also lead the incident response and forensics team for Intel Security. And I have this problem. I am addicted to GIAC certs, right? So I don't know how to stop. And I've been also collecting some titles, right, for some time, like penetration tester, incident response analyst, forensic analyst. But I still have to add that one, chaos specialist. I love that one. But yeah, I've been doing all of this for a while. So when you've been doing all of this for a while, and you've been coding a little bit, I'm a Spaniard, so I'm a bit lazy, right? So I want to code like something quick and dirty. And so when you've been doing this for a while, you come up with solutions, right? And all you probably need is just a bit of time to do actual work. And anyone here from the Northeast? Probably, from my accent, you can tell I haven't been here for a long time. But I live in Northeast New York area, and you probably remember, I think it was like a couple of years ago, the Snowmageddon, right, thing that ended up being a little Mageddon. Well, that was pretty much the thing, right? It wasn't that bad. But it actually gave me like 2 days where people shut down the city and no trains, nothing, so you couldn't commute into an office. And this is how you define work, right? That's how I define work. The absence of going to the office, so you can actually do stuff. So it was like, now I'm gonna be able to work on something that I wanted to work, specifically for a project I was working on. And this is a challenge that I had, right? I was working with a customer, and you've probably seen this. It might resonate with what you have in your own organizations. Large organization with 50,000 plus endpoints that were managed by a central solution, right? In this case, I mentioned it's the McAfee PO agent, but it could be anything else, right? In this case, this is what they had. And they had like a large environment and no forensics in place. So essentially the guys, the field services guys, that would be just running around, running antivirus scans. When you see that a machine was infected with something, what they would do, run another scan, another antivirus scan, and if they found anything, what they do next? They run another scan again, right? Obviously, because you're going to find something at the third scan or fourth scan. Maybe not. So what happens in the end, right? If that machine keeps reinfecting, you just re-image the machine and you just bring a new one. Does it resonate with maybe what happens in any of your environments? What are you learning from that? Absolutely nothing, right? So this is the kind of the environment we were dealing with, and containment remediation pretty much was exactly the same thing. So how do you know what's going on with those systems, right? This is like the kind of the typical day, average day for a SOC analyst. You see something like this. This is an alert for a system that is identified as suspicious because it's going to an IP address that has been collected in this project, Collective Intelligence Framework, awesome open source project that brings feeds from different places, right, open source sources. And if you see that this machine is connecting to this other IP address or domain that is deemed as suspicious, you want to know what's going on, right? But what if the antivirus says the endpoint, whatever you have on the endpoint says there's nothing wrong with this system? Why is this machine connecting to an IP address in Russia or Ukraine or Brazil if I don't have any business with these folks, right? Why is that happening? You need additional context, right? And if you find that there is something malicious on that box, how is that impacting my business, right? Do you have enough information to know what's the response strategy? And we've had an awesome talk from Matt, right, from Google mentioning this. Rob Lee also touched on that. How important is to know what are you facing, what are you dealing with in terms of strategy? We've seen this, summer 2012, largest IR we saw up to that date. 30,000 machines destroyed in the Middle East, largest oil and gas company in the world. Right? You probably remember this. 30,000 machines destroyed as a result of a bad containment. Right? So would you be tipping off the attacker if you're just disconnecting machines here and there, pulling off the cable? May the attacker just change the tactic or take retaliation and destroy the whole environment? So that becomes relevant, right, when you do IR. So that's really important. So we had to prototype a solution, like quick and dirty. And when I was thinking about this, it was like, okay, what can I do that I can bring into the office into just 2 days, and with what we have, build some basic triage, forensics, more than forensics, like collection, right? Forensic collection, live response capabilities into this environment that is highly, highly mature. It must be something that must be cross-platform, must support automated response. You should be able to grab tools that are already out there, like sys-internal tools. Right? You don't have to reinvent the wheel. There are awesome tools out there that will collect all the information that you need from Autoruns, for instance, or things like that. You don't have to write that from scratch. Just reuse it. And also, it should give me the opportunity to scan for indicators of compromise, right? To do threat hunting. So how do you prototype something like that quick and dirty without actually having to use or deploy an additional agent, right? The Google Rapid Response project is an awesome project, but for this particular case, I couldn't deploy an additional agent, right? So how can I do this in a short amount of time? So, Python allows me to do this. I mentioned before, I'm a lazy coder, right? So Python is awesome for that. Lots of examples out there, lots of books out there, lots of security dedicated libraries and snippets that you can use. It also supports the idea of building a RESTful API, which is awesome to design client and server services, right? You can also use something like PyInstaller to freeze or to package your Python code into a single file, a portable executable, a binary that now you can push to your endpoints or use in your Windows environment. So really awesome, right? And even better, it's named after the awesome Monty Python. So what can be better than that? Right? So what do we need to automate? We know all of this. Everyone here in this room, we've touched on some of those things that you have to collect, some of the things you have to hunt for. So for instance, the guys from Endgame have been mentioning this, things you have to collect to examine the machines. And taking the challenge that Rob Lee mentioned in the beginning, how do I define threat hunting? Or more appropriately, how do I use threat hunting? Obviously, we would use it proactively to search for the bad guys, the attackers in our infrastructure, but also something very important that I just touched on, the idea of scoping the incident, right? Once you have found something suspicious in a machine, you want to grab that binary, you want to see what's going on with that binary, and now create some kind of rule that will allow you to sweep your environment and see if there is anything that is suspicious in any other system, right, in your environment. So you can scope what would be the impact, what's the attacker's TTPs, right? Is this something that no one has seen before? Is this something that could be targeted? So now you can define a good scope and then move into containment, eradication, and lessons learned. Again, with Yara, I'm not going to touch a lot on this. A lot of it has been mentioned. I just want to add something that probably hasn't been mentioned before on this repository, Yara Rules. Anyone knows yararules.com? Some of you? Cool. It's awesome, right? It's a great repository. It's actually run by a friend of mine in Spain. These folks have also a Twitter account, yararules.com, Yara Rules on Twitter. So follow them, go to their repository. They have a huge collection of Yara rules on GitHub that might be something you can use straight away in your environment. And the good thing about Yara is that you can call these libraries from your own Python code. So you can write your own code and now run Yara scans on the endpoints using these libraries and scanning memory and scanning also for artifacts on disk, right? And you may have been in this situation before. You may need to deploy a security tool that you want, right? And it's like, oh, I need to deploy an additional agent. And you go to management, and sometimes this is what happens, right? When you say you want to deploy an additional agent, or best case scenario, it might take you like sometime between 3 months or 6 months to get that approved, right? Because now people have to figure out whether that's going to make the machine slow or what's going to be the impact on that. So what is the solution that we came up with? This is how I call the project. It's called Rastreador. And I know it sounds weird. It comes from Spanish, from hunter, right? So hunter, Rastreador, bit of the elite thing, modifying the D with a 2. That's the whole deal. Maybe we can do a poll if we want to change the name, something like that. But it's open source, right? So the code is out there. If Bam Vischer had actually to apologize for the quality of the code, I don't know what to say myself. I would have to say I will have to pay you to actually use this as a compensation or something like that. But it's out there. You can reuse it. I have the binaries already compiled for you. If you don't trust my binaries, which is a good thing to do, you can compile them yourself. But essentially, it uses a RESTful API, so you can do Yara scans and report back to the server. It's easy to integrate with any kind of tool that you have on the endpoint. So if you already have an agent that can kick off a process or kick off a binary, you can use that. That wraps certain third-party tools. So I'll show you some demos if this works. Hello? There you go. So the current functionality in version 0.7, I made it to 0.7 like Swiel. I'm so pumped. I'm a huge fan of Swiel. So we have Yara disk, Yara memdump, and triage. So you can scan for IOCs in memory. You can scan for IOCs on the disk. Pull a memory dump. So when you see that a system is behaving suspiciously, you can just get a memory dump immediately across the network using WinPMem. It's also embedded into the Recall Google project. And you can also triage the endpoints and get information out of them. So this is just a small diagram on how you would do that. Essentially, what you need is 2 folders, a read-only share, where you have all the binaries, all the tools, like the sysinternal tools, everything you want to run on the endpoint, and then a write-only share, where you have where you dump all the results of that triage process, right? So all the artifacts are going to be written to that share on your network. And also, there is another piece, which is a Yara server that is going to be used to pull the Yara rules and also to write the results of the Yara scans via a RESTful API. So something that you can integrate straight away. Now, the next few slides is just for you as a reference, right? I'm not going to read these, but since we're going to share the slides with you, you can see how to invoke this. It's all command line based. Why? Because command line is sexy, right? It's cool for us geeks. And it's just based on parameters. So it's very flexible, very modular, and allows you to just modify the behavior of the tool just by adding different parameters. So this is just like a quick demo, a 1-minute video. Let's see if it works. There you go. Where you can see Rastreador, we're going to do a triage. So we're going to, from the command line, get information out of a machine, right? And we're going to use a triage module. And there is 2 folders, shared folders. One is the write-only folder, where there's going to be created a particular folder for each of the machines that you investigate with a host name. And then inside that folder, you will have another specific folder for each of the timestamps where that has been executed, right? And inside those folders, you will get the results. So this is from the command line, right? You can see all the different tools that are being run or executed on the endpoint, and all the different timestamps where this was executed. and you have just a sample of the output, right? Just Windows commands like ARP or the DNS cache, any kind of information you wanna get from those systems, right? No rocket science here. Something that you probably have already automated in your environment, maybe not, right? But it's something that I found useful in different engagements, and I thought I wanted to to share with you guys. So something also you can do is to modify some of the batch scripts that I already have on the read-only share. So if you want to execute any kind of Windows command, native commands with WMIC or anything like that, you don't have to modify the code. You just go to the share and add whatever you want to execute on the endpoint, and Rastreator will just take it and write the output to the write-only share. This is what it looks like with all different folders. Also, you can grab memory dump, right? So you can get a memory dump of that machine, so you can analyze it later with volatility or recall. And this is what it looks like, right? You're just using a WinPMem and a full memory dump on raw format. So for the EraPieced, what you do is you start a server. It's a RESTful API server written in Python. Again, you have the binary, so you can run that on Windows, but also on Mac or Linux. And it's going to listen on port 8080. And from there, you can run Rastreator with a set of Yara rules you can get from yararules.com, or create your own rules, and scan for IOCs both in memory and on the disk. And that's kind of the format that you would use. So again, just a short 1-minute video that I can. All right, let's go for it. There you go. So that's the format of the command line, and this is YaraMem or Yara disk. We're going to start the server that's going to be listening on this box. It's going to bind to all the interfaces and listen on port 8080. And now we can run a memory scan, right? Looking at connecting to the server on local host, and I'm going to use fake malware Yara rule from Florian Roth that is on yararules.com. It's going to scan physical memory, and it's not going to find anything. You can see here the RESTful API. It's pulling the Yara rule from the server and executing that scan on the endpoint. Right? I always say never go hunting on a Friday. I always said that before listening to Heather's talk, right? But after that, I would say, never go hunting on a Friday unless you work for her, and then that's perfect fit. But this is the same thing. Now we're doing this on the disk, right? So in this case, I have a file that will be actually detected, and it will just create a simple TXT file, text-based file, on the same directory where the server is being executed from, and you will see this file will be populated with the details of the scan. So if there's been a match, you will get a timestamp, the host name, because you might be running this across hundreds of systems, and you can see where this was found, the module that was used, whether it was on memory or on disk, the process where it was found, right, if it was a process, or the file where this was found, if it's a file on the disk, right? And so just based on this, how would we be solving the problem that we mentioned before, right? Like 2 days later with something like this, you go back to the office, how would you be able to get more context out of an alert like this? Well, if we would run the tool, and this is where it becomes like really useful to see the integration with some of the tools you might already have in your environment. And in this particular case, it's just like McAfee EPO, but you could use this through SSCM or whatever mechanism you can use in your environment to push these binaries. This is just a client task that we define. So we define a client task for pulling memory dumps. We define another client task for doing triage on the endpoint. So exactly the same arguments, command line arguments that we have. We just write them here, and we create those client tasks. We go back to the dashboard. We look at the system we want to investigate. And the cool thing about this is that now you can enable the people that is in the SOC that uses these tools like point-and-click tools to actually collect artifacts and do kind of threat hunting without actually having to open up a command line and do more advanced stuff, right? So it integrates these threat hunting and incident response procedures and tools into the workflow that you already have in your organization. You can see now here, now executing the task, and you just have to go to the share, and the share will be populated with the memory dump and all the information that you have from this machine within minutes. So typically, in this particular environment, within like 5 minutes, you can get like a 4 gig memory dump, and maybe like 6 or 7 minutes, you can get all the information from the triage. So in this particular case, you look at the Autoruns, you see a high entropy name, so something weird, something you want to investigate. You look at that, and you also find on the DNS cache resolution for this mail.ru, right? Highly suspicious, what's going on with this box. You have already identified the file that you want to look at, so you pull the file, you check the hashes with VirusTotal. Awesome tool, by the way, PE Studio, right? Something you can use. And you see that this is a spam bot that also steals credentials and do some other kind of stuff, right? So that's just an example of what you can do with something like this. Now the next step would be how to now scope the whole of the incident, right? Based on that sample, you can go to YaraGen, for instance, generate a Yara rule, and now do a search across all your environment to see if this particular malware has been seen anywhere else, even though you might not even have detections from your endpoint solution. So that's it pretty much. That's the benefit of having something like this in like 2-3 days. Now in this particular environment, we were able to add these capabilities to the SOC, where now they could do threat hunting and do some other incident response and triage in a quick and dirty way, right? This is by no means anything as cool or fancy or advanced as many of the tools that we have mentioned during the day. But it's open source, it's out there, you have the code, use it, right? Documentation is really bad because there's almost no documentation. But you have my details, right? So please use it. I would like to have your feedback on it if you're using it. And that's it. Thank you very much for your attention.